Let's come to section 3.3, solving exponential equation using logs. So keep in mind that last time we talked about log, and we actually have some idea to solve the equations of log, the equation of exponential by using log. So as you see that example 3.7 there, we can apply log both sides to solve it. So that could be the reason. Okay. So now we can specifically on solving exponential equations in this section. And let's start with example 3.12. Solving the exponential, solve for the exponent in the equation. Okay, so right now we are having an exponential equations, and we need to solve for the x, which right now is in the exponent. Okay, so step one, let me show you, is isolate the exponential term. Okay, so how to do that? I need to have, I'm gonna divide both side by 5. Okay. Divide both side by 5. So then I will have in the left is 0.93x. And the right will be 2. Okay, so I come up right now with just, isolated the exponential term already. Okay, we come to step 2, which is take log both sides, right? So as you see right now, I have isolated the exponential term. So similar with examples 3.7 here. Okay. I just need to take log both sides. All right. Log both sides. So what do they have now? I'm gonna have logs 0.93 raised over x equal to 2. Oh, I forgot something, right? Log of 2. And keep in mind that the reason I do this step is I can move the x from the exponent down to the front of log. So it's no longer become an exponent, right? And I can have x some log of 0.93, which equals to log 2. Okay, and that will give us as x equal to log 2 divided by logs of 0.93. Okay, and at this step, you can just use calculator and say, log 2 divided by log 0.93. And you're gonna get negative 9.55. Yes, as the answer for that. Okay. So it's always gonna follow by the two main steps to solve for an exponential equations, like what I'm doing here. Always isolate the exponential term and then take log both sides. The reason to take log is to move the exponent down. Okay, that is the main reason. Okay, now next we're gonna move to next example, 3.13. Okay, so we have into the NA population of Kenya was 38.8 million, and it was growing by 2.64% each year. The other city was population of Sudan is approximate at 41.3 million and growing by 2.24% each year. So if this trend continue, when will the population Kenya match the Sudan? So we want to have when two of these gonna be when two population of this gonna be equal each other. So let's say if I have Kenya as a function of function with t, we have initials value right now. Let's say start from 2008 is 338.8 time with 1 plus 0.0264 raised to power t. Because you know that we are having with a equal to 38.8 million and r equal to 2.64%, which equal to 0.0264. And similarly for Sudan, I write Sudan of t will be a function with initial amount is 41.3, right? Time with 1 plus 0. What is the rate of that? 0.024 raised to power t. Okay, and for this one we have with a equal to 41.3 million, r is 2.24. 2.24. So then this should be 2.24 here. And we are using let me just let's use function exponential function form in in growth rate form, which is f of x equal to a times 1 plus r raised to t, right? Yeah, it is exponential function in growth rate form. Okay, and now we're gonna have we want to have let's use since we want population Kenya equal to the population of Sudan. So then that means we want Kenya T equal to Sudan T. And that means we can set up the function as 38.8 times 1 plus 0.0264. Actually, you know what? I'm gonna simplify this to be 38.8 with 1.0264 raised to t. And this one will be only 1.3 with 1.0224 raised to t. Okay. So then I will change it to be 1.0264 to t equal to this guy. And again, like I said, this is exponential equation. You must start with step 1, isolate the exponential term, right? Okay. So how to do that? You will, I will go up a little bit. Okay, so I will divide, so 38.8, 1.0264 to t equal to 41.3 times 1.0224 to t. I will divide both sides by 1.0224 t, because I want the exponential term, all the exponential term in the left hand side. And I also will divide both sides the column by 38.8. 1.0224 to t. So now I can just have the left hand side become only 1.0264 raised to t divided by 1.2 1.0224 raised to t. And the right hand side become 41.3 divided by 38.8. All right. So let's simplify. I mean, right now, I have the left have like a fraction form with two exponential form, right? And according to the rule that if you have say you have something like a raised to n over b raised to n, you can combine them to be a over b, everything raised to n. Okay, so you can have a that's rule. Okay, to apply into the left and get to 1.0264 divided by 1.0224 raised to t, and make is equal to 41.3 divided by 38.8. And at this point, now you have exactly only one term of, I mean, only one exponent, only one exponential term in the left, and it has been isolated. Okay. Now we're gonna move to the next term. I mean, the next step. Use this one as a red. Okay. Second step is take log both sides. The reason to take log both sides is to move down. Okay. In order to move down, the variables. Okay. So the variables was t from the exponent. Now move down. If I can, if you want, I can do that right now, but I have to do log both sides first. So let's do log both sides. Log of 1.0264 over 1.0224 raised to t will be equal to logs 41.3 38.8. Okay, if someone is gonna ask me like, can I do logs, natural logs instead of logs? Yes, you can do that. That's gonna be okay too. Okay, that's also a log. So you can also apply the exponent property of log to move down the power the t from the exponent down to down to the front of the log. So now you will have t time with log of 1.0264 divided by 1.0224, and you will have logs of 41.3 divided by 38.8. Okay. All right. So we can now find t by trying to isolate t alone, right? So you can think about divide both sides by this guy to get to have isolate t alone. So have t will be equal to log 41.3 over 38.8. Everything divided by loss of 1.0264 divided by 1.0224, and you will get, okay, now you're gonna have use a calculator. Let me show you this. This is a little challenge if you don't know how to use calculators. So now let's start with log, right? If you put like this, 41.3, okay, and divide by 38.8, close the parenthesis, okay, and then divide by log of 1.0264 divided by 1.0224. Okay, so that. Then you can enter, and you have the answer as 15.991, right? I'm gonna say approximately 15.991. So you can round it to the nearest years. I'm gonna say 16 years. Okay. Then you will say in almost 16 years. Since when? Since 2008, right? Because we start from 2008 here as initial. The population student, or maybe in students in Kenya will be equal. Okay. So this is going to be it. All right. Let me make sure that I answer the question. When will the population up? Okay, so that's what we need, right? Maybe if you want to be specific, like in almost 16 years, since 2009, and that mean is what years? I would say like 2008, adding with 16 is 2024. Or 2024. Okay. Okay. So that's gonna be it. Okay. So I would love to let you guys practice on 3.13. And Let's see. Here. Okay. So I give you the answer key for this guy. Make sure to follow by 2 steps I show you. This will be 8.2 approximately. Okay. And the next one also we'll have to solve for x. I'm gonna do this one with you guys together. So when you have exponential equation, first, like I said, try to have try to isolate the exponential term, right? Okay. Let me right. And then what I do in here, say I have 2.5 times with 1.03 x equal to 4.6 times with 1.02 x, right? So you need to divide both sides by 2.5 to get rid of that 2.5. And you also will divide both sides by 1.02. You know what? I want to step by step to make sure you can easily follow. Let's then we just start by divide both sides by 2.5 first. Right. You will have what? Then size 1.03 equal to 4.6 over 2.5. And multiplied by 1.02 raised to x. Now, I want to have the left-hand side have just all the term width variable, right? So move all the term variables by divide both sides by 1.02. Right, see that? So left now become 1.03x divided by 1.02 x. Equal to 1.6 divided by 2.5. Yeah. So, I mean, if you're really strong, already you can think about that can come from that step right away to here. First, because you can just always think that you have to divide both side by, I mean, you have to move all the term that have variables in one hand side and other term with a constant to the other hand side. So you have 1.03 over 1.02, everything's with x, right? Because you remember the rule that I told you, right? You will have 4.6 over 2.5. Okay, now you did finish step 1 because you did isolate the exponential term. And then you're going to go ahead and move to step 2, which is take logs both sides to in order to move down the x, right? Because you want this x going down. So let's say, you know what? I'm gonna change that time. I'm gonna change the logs. I'm gonna say take natural log both sides this time. Okay, it should be the same, just using different base. So take natural log both sides. 1.03 over 1.02 x equal to natural log of 4.6 over 2.5. And at this point, you can move the x in front of the log. Oh, sorry. Okay. I with natural log of 1.03 divided by 1.02 equal to natural log of 4.6 over 2.5. And now you can just divide both sides. It's going to be x equal to natural log of 4.6 over 2.5. Everything over natural log of 1.03 divided by 1.02. Yeah. And at this point, you can use the calculators to calculate that. So n 4.6 divided by 2.5. So that, and then divided by ln of 1.03 divided by 1.02. So that's, and you have 62.5. 62.5. So that's going to be the answer of this one. gonna box this one. Right. So that's gonna be it. And now we move to the next examples, which is solve for x in the equation. So in this case, as you see, we have exponential equation with same base, right? Same base, same base both sides. So you don't have to, in this case, you can just make the exponent. You can just make exponent equal each other, right? Because 3 raised to x is going to be equal to 3 raised to something. So I can just make as x going to be equal to 5x minus 8. So then I'm gonna subtract both sides by x, or maybe no, actually I'm gonna subtract both sides by 5x. I'm gonna have negative 4x equal to negative 8. Then I'm gonna divide both sides by negative 4. I'm gonna have negative 8 divided by negative 4. So then that means x will be equal to 2. Okay. Okay, sometime instead of giving you like a exponential equation, I'm giving you as a log equation. Okay, so right now look at the log equation. All right, and both sides have log, and you can see that we have same base. Same base of log. That means the inside are equal. The inside of parentheses or the argument I usually say are equal. Right? So I will have announce as x squared minus 8 equal to negative 3x. I don't even have to have the parentheses. Plus 2. I just forget the log. I don't need the log anymore, right? And then I will add both sides by 3x. And minus 2, both sides. Because I want to I want to move all the term in the right to the left. The reason was I'm having x squared. We look like I'm gonna have a quadratic equation. So gonna be x squared plus 3x minus 0. So at this point, you would think about AC method. All right. 2 number multiply equal to negative 10. Or maybe I'm gonna Side here. B equal to 3. Okay, so two number multiplied to negative 10 will be what? Will be 5 and negative 2, right? So that also give me right away as keep my that A in this case is 1, so special K. We're gonna give us x plus 5 and x minus 2 equals 0. And factor probability, I'm gonna have x equal to -5 or x equal to 2 as the answer for this one. Okay. However, we need to check. Okay. However, we need to check solution for log equation. So how to check? You need to plug back the -5 into the equation and see if it works. Okay. Let's say we have log -5 square you can just check the inside only. So net 5 square minus 8. What is that equal to? 25 minus 8, which is 16. Is that? No. 17. It's greater than 0. Right? That's what. That's good. But let's check with the one, the other inside. We have -3, have -5 plus with 2. What is that? -15. No, 15 for 2, only 17. That is good. Right? This is good. So both of them greater than 0. That's the fact. That is good. So x equals to -5 is a solution. What about check x equal to 2? And let's say 2 square minus 8. What is that equal to? 4 minus 8, -4. It's 0, less than 0. So then x equal to 2 is not a solution. Okay? So it is make the inside of log less than 0. That's gonna make not a solution. Okay? So there's only one solution in here will be valid is x equals to -5. Okay. So I will go ahead and let you working on exercise 3.15. And the answer key for the first one is x equal to 3. And this one, I'm going to say x equal to 1 or 5. All right, so I'm going to stop this session here. We'll see you in the next session at 3.5. Have a great day.